The answer leaps to the eye. Tin is a natural resource of our country. And if you ask me, we have at least $30 billion worth of untapped potential underground. We're not talking about tin deposits offshore, on the shore. But there it is. So we have been rather complacent in the past, just digging the tin and exporting it. But tin is a fantastic, it's a very versatile metal. It's an evergreen metal, and the reasons for it. I mean, if you throw it out into the rubbish, you can extract it out magnetically, so it doesn't contribute to pollution. There are a lot of tin plate, for example, tin plate, you make it tin cans, and then you have tin soldiers. So they have been the long-standing uses of tin. But tin, as I say, is a very versatile metal. You can make chemicals out of tin. Tin-based chemicals, the inorganic chemicals. Tin oxide, for example, cassiterite is found in the earth, is a tin oxide. So that also has a very long established uses. But what we were interested in is to work on a new class of compounds called organotin compounds, which is part of the greater field of organometallic chemistry. Organometallic, the word organic means carbon-containing. In the case of organotin compounds, we have direct tin carbon bonds. And depending on the number of carbon bonds to tin, you can get chemical activity or biological activity. Now, this biological activity, some evidence of it was procured even before when I was schooling, in the 1950s. But it remained dormant for a while. I mean, and some applications were found. But we ventured into structure activity studies. That means basically, if you look at the organotin compounds, tin is in the oxidation state, as we chemists say, oxidation state 4. There are 4 groups that can be attached to tin. You can have one organic group attached to tin, they call monoorganotin. And you have 2 is diorgano, and 3 means triorgano. It was all 4 organic groups. So these are tin covalent bonds. Now, the biological activity is maximal when you have 3 organic groups on tin. So immediately our focus of attention was on triorganotin compounds. You can represent it as I showed in the diagram there, R3 SNX. SN is a symbol for tin, stannum. X is the anionic group, like chloride, hydroxide, acetate. Organic groups can vary. Can be alkyl chain, long carb, methyl, ethyl, butyl, or octyl chain. Now, if it's an octyl chain, 8 carbon atoms, but each R group has 8 carbon atoms, is not toxic. So the toxicity depends on the nature of the R group. What we found was, by varying the R group, putting aromatic groups, heterocyclic groups, and other groups, alkyl chain groups, or mixed groups, you can alter not only get enhanced activity, you get specificity of action. And that also applies to the anionic residue, the X group. It has long been thought that X group has hardly any effect. But we found, to our surprise, that remote substituents, for example, the esteryl group or carboxylate groups, really influences activity as well. So we looked at economically important pests of Malaysia. We looked at 2 areas: industrial biocides and crop protectants. Other biological tests were also done, like cytotoxicity tests, anti-tumor studies, against the mosquito larvae and all that. But the agricultural ones are very important because we looked at fungi, we looked at insects that affect various crops, oil palm, pepper, cocoa, rice, including storage of grains. That we looked at that. Then we looked at timber. Wood protection as an industrial biocide case. Rubber wood is used everywhere in furniture and is exported. But you can impregnate the wood with this organotin compound that give you protection against fungi and insects. And we did this on in vitro, in vivo in the field for over 1 year. We did the study, dug the rubber stakes out of the ground, and look, the termites are not even affected there. So these were very specific discoveries there, which we have patented, and we have even published some of these results. And then we looked at paint spoilage fungi. Paints get spoiled by fungi. Again, you have masonry being spoiled. So we can treat all these things with organotin compounds. We also looked, while we're looking at it, we also looked at the biochemical aspects, how exactly it exerts its toxicity. So this is a bit out of depth for this introduction, but we have published the details of this, and we were the first to show a number of important properties and novel properties. But what we were equally surprised is, although we ventured into applied research, we got a bonus. Under the umbrella of applied research, we did a lot of pure research as well into the structure activities. Very novel structures were obtained. And this has really enriched organotin chemistry as a whole. And I'm very happy that it's the first indigenous effort of its kind in the country, which won the university world-class recognition. We had scientists from all over the world coming to work in our laboratories. And I had a fantastic group of very passionate researchers who worked round the clock with me and helped build up this project. So I'm still excited. I'm now trying to push the downstream application of tin. We are going to have possibly in 2014, or if not in 2015, a tin chemicals conference here in this country, where tin manufacturers, tin users are all be coming here. So we're hoping that State of Perak, where I was my last service was the State of Perak, and I talked to Ahmad Muhammad, the Menteri Besar there. He seems excited. I think we should go downstream. So thank you for this opportunity to market the research area. Challenges were many. Come in different shapes and sizes, and you wouldn't expect.
What are the names of the two universities?
Yeah, the first one was, this is soon after my retirement from University of Malaya. I was handpicked to be the first Vice Chancellor and to establish the university, AIMS University in Jeddah. So I served for 2 terms there, and we set up a lot of faculties. It's recruitment of staff, curriculum development, linkages, liaison with the government agencies, making sure that the standards are met. At the same time, educating the investors. That's a mind bug, because they tend to be involved in micromanaging. So look, let the professionals do the job. So very often you cannot. It's always it's a tussle, And then educating them. Look, it's a long-term investment. Higher education is big business, but do not look for short-term ROI, return of interest. It's at least 5 years and beyond. And if you start on a small key, then of course it is different. But if you want all the heavyweight programs like medicine, dentistry, engineering all to come in, then the scale of investment is high. So first of all, we look at what is the philosophy. First of all, establish the constitutional university, the Senate, the entire, so that the integrity of academic integrity is guaranteed. We follow the guidelines given by the Ministry of Higher Education, and they've set up some very good guidelines, which always helps in people like us who come from public university background and trying to do something. We know the mistakes that have been made or continue to be made in the public university. We try and rectify it. In a private enterprise, you can go farther than that, but the necessity is money. You've got to develop courses that are competitive, market appeal, and you must prepare the students ready for the market as well. At the same time, the role of the university is not just disseminating knowledge, it's creating knowledge. So if you want to recruit good staff, you must have the seed money for research and excite them into research. The fruits of research that are automatically translated into teaching. That's how it should be. I think the world is changing. If you ask me for the next 2 decades or 3 decades, the focus of research in science is multidisciplinary anyway. It's no longer, chemistry. There's no problem outside there called chemistry. You have to have inputs from various quarters into solving a problem. I'm not saying just the environment to environmental chemistry per se. What I'm saying is the areas of research are energy, chemical synthesis and catalysis, biological chemistry, and material science. These are the areas, and a lot of fields overlap coming into this. So even in like my field of research, you could say I was in biological chemistry. When I went to do research in the biological, I had a multidisciplinary group. I learned my biology from that. I wrote biology papers. So just because you did not study a particular subject at the university or school level doesn't mean that you cannot embark on a new area. So be bold. Look at areas. And if you have the chance to do postgraduate research, try and spend some time working in the research labs of some top scientists in the world. We are global. Do not be short-sighted and just focus. I know many of my younger staff in those days, when they took sabbatical leave, they just remained in the country. That is not how it should be. You should broaden your horizons, get new ideas for research, and involve industry in research. Because that's important for us.
Thank you, Dr. That's it.